Hello all and welcome back to yet another discussion on the JEE papers. In today's lecture, we are going to look at the JEE main paper which appeared in January session of examinations. So we'll have an in-detail analysis of this question paper and we'll try and solve different kinds of problems, though not the entire paper, but a wide variety of questions. So talking about the JEE main syllabus, this syllabus is more or less exactly like the NCERT syllabus. Only in few topics such as coordinate geometry, especially conic sections, you'll have to go a little beyond NCERT textbooks and explore these topics from probably one of those recommended JEE main textbooks. Apart from this, if you stick to your NCERT textbooks and solve a wide variety of questions, you should be able to crack JEE main examination with very little effort. So, what happens in the JEE main examination? In the JEE main examination, you have 30 questions from each section. In 2019, this is what was the pattern. Physics, chemistry and math, each section, 30 questions appeared from them. Now, all these 90 questions put together will have 3 hours to solve, which means more or less in an hour, you are supposed to solve all the questions from a particular subject. Now, math, 30 questions, these generally will take a little more than an hour to solve, but in order to solve them in 1 hour, you should ensure that you've done a lot of practice and you are aware of the types of questions which come. In fact, the types of questions which come do not vary a lot year after year because there is a set pattern in the JEE main examination. In the JEE main examination, every topic from the NCERT textbook will be covered and more or less a question comes from each of these topics. So broadly, I am going to divide your JEE main syllabus into 4 different sections for mathematics. You have algebra, you have calculus, you have coordinate geometry, and then you have probability. Now, let's focus first on calculus because I love calculus and calculus is one of the most interesting sections which fetches a lot of questions. In this paper that I'm going to analyze, there were 9 questions which came from calculus alone. And what is more interesting is the fact that 4 of these questions were integration questions. So 4 out of 30, now that's quite a big number, isn't it? 4 out of 30 is slightly less than about 15% of your question paper. So almost 15% of your question paper was integration. So integration is one very important topic in the JEE main examination. And so the first question that I will be solving today live will be an integration question. So let's try and solve this integration question. Here we go. In this question, we've been asked to find the area bounded by y is equal to x square minus 1 and the tangent to this parabola at the point 2, 3. Now, this is a very interesting integration question because this involves a little bit of conic sections also, but it's more or less a very straightforward calculus question. The first thing that we are going to do is we are going to find out what is the equation of the tangent at 2, 3 to this curve y is equal to x square minus 1. So how do you go about this? The first thing that we do is find out the slope of the tangent using differentiation. So dy by dx turns out to be 2x and at 2, 3 the value of 2x is equal to 4. So the slope of the tangent at 2, 3 to the parabola is equal to 4. So I know the slope of the tangent, I know the point through which the tangent passes. Now it's very trivial to find out what is the equation of this tangent. I'm going to use the point slope form. Y minus 3 is equal to the slope 4 times x minus the x coordinate which is equal to 2. Simplify it and you get y is equal to 4x minus 5. So now I have the curve which is y is equal to x square minus 1. I also have the equation of the tangent at 2, 3 which is y is equal to 4x minus 5. So the first thing that we need to do in order to compute the area bounded between these curves is draw the figure, and this is how the figure looks like. Now if you closely analyze this figure, you will find out that the area bounded between the curves is actually equal to this big triangle here minus the area that is under the parabola. But there is a small catch here. This is not integration with respect to x, but this is integration with respect to y. If you try to integrate it with respect to x, you can still arrive at the answer, but the process of integration will be longer, and that is not what we want in the main examination. In the main examination, we want to look at things through which we can do a question in the easiest possible way. So I'm going to integrate with respect to y. This is what happens. The area of the triangle is 1/2 times 8. There are 8 units along the y-axis, and the distance along the x-axis is 2. So 1/2 times 8 times 2, which gives me an answer of 8, minus the integral from -1 to 3. So these are the coordinates along the y-axis, whose area that we have to subtract, the area of the parabola that has to be subtracted. So integral from -1 to 3 of the under root of y plus 1, because the equation of the parabola was y is equal to x square minus 1. Now I'm going to express it in terms of x. So x will be equal to under root of y plus 1, and then integrate with respect to y. So dy. A very simple integration question. If you go through the whole thing, you will get that the area under the parabola is actually equal to 16/3 square units. So 8 minus 16/3 square units is actually the area between the parabola and the tangent to the parabola at 2,3. So the area turns out to be equal to 8/3 square units, and this was given in option C. So option C is the correct answer to this very simple question. You could have done this question as an integration with respect to x as well, but then it would have taken you more time, and in the JEE main examination, time is invaluable, so you must try and save as much time as possible. So we have integrated with respect to y and arrived at the answer with a very short span of time. This was a very interesting question from integration. I'm going to solve one more question, this being an indefinite integral question, which also appeared in the question paper. Integration had a lot of questions, so we will do one more question to make sure that we have a very sound understanding of integration. So in this indefinite integration, we've been asked to simplify this integral and arrive at the answer. So we have to find out the integral of x multiplied by this entire term, which is under the square root, times dx. Doesn't seem to be very trivial, but if we make a proper substitution, then the question becomes easy. So whenever an indefinite integral question comes, the first thought that should come to your head is, can I make use of some substitution? Look at what is there inside the integrand. We have an x multiplying the square root of a lot of sine terms, and the argument of sines everywhere is x square minus 1. What is the differential of x square minus 1? It is 2x dx. So we have an x dx, and the argument is x square minus 1. So if x square minus 1 is my t, then x dx is nothing but 1/2 of dt. So now I'm going to make that substitution, and my integral will now reduce to this form, which is 1/2 of the integral of under root of 2 sine t minus sine 2t divided by 2 sine t plus sine 2t dt. Very simple conversion. Now what do I do? Now, can I not write sine 2t as sine t into cos t? Of course I can do that, right? So I'm going to write sine 2t as sine t cos t. No, there is a 2 that has to be multiplied to it, because sine 2t is 2 sine t cos t. So I'm going to write sine 2t as 2 sine t cos t. So now if you see, each of my terms will have a sine t term here, right? And a 2 as well. So I can cancel out all the 2's and the sine t's, and what is under the root now very simply becomes 1 minus cos t divided by 1 plus cos t. It is now reduced to a very simple form, and as soon as you see 1 minus cos t divided by 1 plus cos t, you should understand that we are supposed to make use of tan half angle formula, because under root of 1 minus cos t divided by 1 plus cos t is nothing but tan t by 2, because tan square t by 2 is 1 minus cos t divided by 1 plus cos t, so the under root of that would be tan t by 2. So now the integral has been reduced to 1/2 of the integral of tan t by 2 dt. Now you know how to integrate tan t by 2, isn't it? The integral of tan x dx is log of secant x dx. So the integral of tan t by 2 dt is the log of secant t by 2 but then you have to divide by a 1/2. So the 1/2 which is outside the integral and the division by 1/2 cancel out, and you are left with log of secant of t by 2. Now just make the back substitution for t. T was x square minus 1. So the final answer is the log of secant of x square minus 1 divided by 2. Of course, because it's a log, we consider the modulus and then plus c. So this is the correct answer, and this was given in option A. So option A, which says that the value of the integral is equal to the log of the modulus of secant of x square minus 1 divided by 2 plus the constant of integration, was the correct answer to this very, very simple question. You should be able to solve this question in less than a minute so that you can allocate the safe time to some other question which requires a lot of time. So this was a very, very easy question from integration. The only trick was to make the correct substitution right in the beginning, and then you could have solved this question very easily. So these are the two questions from integration that I will be solving in this from this question paper. But there were more questions which came from calculus, and one another interesting question which came from calculus came from the section on differential equations. I'm going to show you how simple this differential equation questions was, and then you will understand that even though calculus fetches a lot of questions, solving these questions is actually not very difficult when it comes to the JEE main examination point of view. So in this question from differential equation, we've been given a differential equation which is x dy by dx plus 2y is equal to x square. Further, they have told us that y of 1 equal to 1, and the objective of the question is to find out what is the value of y of half. Is this question in any way difficult? Not at all. Now this question, as soon as you see it, this is a question that you must be able to solve in less than a minute, because this is a straightforward linear differential equation question. All that you have to do is divide throughout by x, and as soon as you do that, your differential equation reduces to dy by dx plus 2 by xy equal to x. Now, what is the integrating factor? The integrating factor is nothing but e to the power integral of 2 by x dx. Now, the integral of 2 by x dx is nothing but 2 log x. Now, 2 log x can be written as log of x square, which means my integrating factor is e to the power log of x square, which is nothing but x square. So my integrating factor 2 is a polynomial, which is very amazing because now I don't have to use integration by parts. So the solution to the differential equation would be y times the integrating factor, which is y times x square. That is equal to the integral of x square times x. So the integrating factor times whatever is on the right hand side, which we call q sometimes. So x square times x. So you look at the beauty of this question. It's such a simple question because now I have to just integrate a polynomial x cube. Integral of x cube is x power 4 by 4. So the solution to the differential equation is y times x square equal to x power 4 by 4 plus the constant of integration. Isn't this a very, very straightforward question, a question that you have solved innumerable times in your NCERT textbooks? Of course it is. That is how easy differential equation question was in this paper of the JEE main examination. So JEE main examination is actually not a very difficult examination if you've practiced your NCERT textbooks really well. So now let's complete the formalities in order to arrive at the solution. We have to find out y of half, for which we need to find out what is the value of c. They have given us one of the conditions, which is y of 1 equal to 1. So substitute the value of xy equal to 1, 1 in the solution to the differential equation, and you will find out the value of c to be equal to 3 by 4. Once you've got the value of c to be equal to 3 by 4, the solution to the differential equation is nothing but y equal to x square divided by 4 plus 3 by 4 x square. What did I do? I just brought the x square over to the other side and wrote this in terms of y as a function of x, because remember, I have to find out y of half. So now I'm going to substitute the value of x equal to half and find out what is the value of y when x equal to half, and upon simplification, I get the value of y of half to be equal to 49 divided by 16. This is given in option C. So 49 by 16 given in option C is the correct answer to this question. Now remember, the only place where you can actually go wrong in this question is numerical calculations. So after all the effort that you have taken to solve the linear differential equation, please do not commit blunders while doing simple numerical calculations. Arrive at the answer, which is 49 by 16. Make sure that you double check it, because this question was a very simple question, wouldn't have taken you more than 30-40 seconds to arrive at the final answer. So just spend about 20 seconds checking your answer and make sure that you mark the correct answer, which is option C, 49 by 16. A very simple question. So now you've seen that calculus, though fetches a lot of questions, the questions are not monstrous. So I keep telling this, calculus is a monstrous section in terms of the number of questions which come, because there are only very few chapters here. There's limit, continuity, differentiability, there is differentiation, and then there is application of differentiation, and then the whole section on integration, its applications and differential equations. So few number of chapters, but still the weightage of questions which come is a lot. So the section is monstrous, but the questions which come are actually gentle questions if you understand calculus very well. So make sure that you have a very sound, strong understanding of calculus. Your foundations are strong. You've gone through all the NCERT questions. Then solving main questions will never ever be difficult when it comes to calculus. Yet another big section in the JEE main examination is coordinate geometry. Now, coordinate geometry is slightly tricky for students who have solved the whole of NCERT textbooks, because the syllabus that is there in JEE is slightly more than what is there in the NCERT textbooks. NCERT textbooks do not speak about a lot of different properties of circles. They do not delve into topics such as the tangent to conic sections. They do not deal with any of the conic sections which are rotated or shifted from the origin. So you'll have to go through all these concepts from some very prescribed textbook for JEE main examination. And once you've seen all these things, then getting into JEE main examination and solving coordinate geometry questions will also not be difficult. I want to quickly take you through a few questions from coordinate geometry. When I speak of coordinate geometry, I speak of all the chapters which involve something with the coordinate axis. These are circles, straight lines, ellipses, parabolas, hyperbolas, three-dimensional geometry, and vectors. So this entire section of coordinate geometry covers all these chapters. And in the main examination, generally 8 to 10 questions come from here. That's again a big chunk of questions. 25 to 30% of your paper is from coordinate geometry as well. So calculus has 25%, coordinate geometry has 25%. So that's like a big bulk which comes from coordinate geometry. So this year there were 8 questions, slightly more than 25% of your marks came from coordinate geometry, and we're going to quickly look at a few questions from coordinate geometry. The objective in this question is to find out the equation of a tangent which is the common tangent to a circle as well as a parabola. Now, what is the circle? X square plus y square minus 6x equal to 0. The parabola is our standard parabola, y square is equal to 4x. Now, you all would be lying if you said that you do not know how to solve this question, because this is a very standard question from the section on conic sections and circles. There is an equation of a conic section and a circle. There is a tangent which is common to both of them. How do you solve it? Find the equation of the tangent to the conic section and then use the property that a tangent is perpendicular to the radius of the circle, which means that the distance of the center of the circle from the tangent is going to be the perpendicular distance. This is the property we're going to use. So the equation of the tangent to the parabola is y is equal to mx plus 1 by m, which can be rewritten as m square x minus my plus 1 equal to 0. So this is the equation in the standard form. Ax plus by plus c is equal to 0 of a line. So now I have got the equation of a line in its standard form. I know the center of the circle. What is the center of the circle? The center of the circle is at 3, 0. Now, what is the distance of the center of the circle from this tangent? Now, the perpendicular distance equal to the radius of the circle. What is the radius of the circle? The radius of the circle is also equal to 3. So, using the formula to find out the distance of a point from a line, we can find out what is the value of m. So, this is the expression to find out the distance of the center of the circle from the tangent and equate it to 3, and you will get the value of m to be equal to plus or minus 1 divided by root 3. So now I'm going to first take m is equal to 1 divided by root 3, plug it in the equation of the tangent, and I get y is equal to x divided by root 3 plus root 3. Multiply throughout by root 3, I get root 3y is equal to x plus 3. Isn't this one of the options given? Of course it is one of the options given, which is option C. So option C, which says that the equation of root 3y equal to x plus 3, this line is a common tangent to both the circle and the parabola, is in fact the correct answer to this question. A very simple, straightforward question which involves concepts of both circles and parabola. So even though such questions are not there in your NCERT textbooks, all those who have prepared seriously for the JEE main examination would have seen such questions in plenty while you were preparing for the examination. So this was a very straightforward question. I'm going to go to another question which is slightly more tricky, not because of the concept involved, but because of the approach that was needed to solve this question. Let's quickly have a look at that question. This was a very interesting question. I liked this question a lot because this question involved you to think a little outside the box. This was probably one of the only questions in this JEE main examination which actually made you think a little outside the box. We were given 3 circles. Now these 3 circles have radii A, B and C in increasing order, with C being the highest and A being the smallest of the 3. The objective was to find out which of the relations given is true, and the condition which was given was that all these 3 circles touch externally. Moreover, the x-axis was a common tangent to all the 3 circles. Now, slightly difficult to visualize. You have a big circle, you have a moderate circle, and you have a small circle. All of them touch externally, and the x-axis is a common tangent to all the 3 circles. Now, could you imagine this figure? If you could, then you have as well as solved this question, because after this, the concept that is going to be used is nothing but the Pythagoras theorem and nothing more. Look at this question now. Now, I'm going to form a few triangles here. See, all these are the different triangles that are formed. Now, we know certain distances here. We know the distances, these distances, because these are going to be the difference of the radii. What are the hypotenuses? The hypotenuses are nothing but the sum of the radii. So one of the sides of these right triangles are going to be the differences of the radii. The hypotenuses are going to be the sum of the radii. So we know 2 sides in terms of the radii, which means that we can find out the third sides. Now let's try and find out the relations. I am going to call this small circle the point where the radius is perpendicular to the tangent x-axis. That point as A, the other thing is B and C. Now using this relation, we can find out that AB plus AC equal to BC, and I can find out AB and AC in terms of the radii, right? Because I know the other 2 sides of that right triangle, so AB and AC can be very easily found out. So let's find out what is AB and what is AC. So this is AB, this is AC. Very simple Pythagoras theorem. So AB will be the under root of B plus A the whole square, which is the hypotenuse, minus B minus A the whole square, and AC will be the under root of C plus A the whole square, which was the hypotenuse, minus C minus A the whole square, which was the length of the other side. Now what is BC? Let's go back to the figure and look at BC. Can we construct a right triangle involving B and C? Of course we can. Again, we know the hypotenuse to be equal to the sum of the radii B and C, and one of the sides to be equal to the difference of B and C. So what is the length of BC? The length of BC is going to be the under root of B plus C the whole square minus C minus B the whole square. In fact, it doesn't matter if you write C minus B or B minus C, because you are squaring it, so it's going to come out to be a positive number. So because C is greater than B, I'm just writing it as C minus B the whole square. Now simplify this. b plus a the whole square will have an a square and b square. B minus a the whole square will also have an a square and b square. Both of them positive. When you're subtracting, those things cancel out. So the only terms which remain under the roots are going to be under root of 4ab plus under root of 4ac equal to the under root of 4bc. So these are the only terms which remain under the root. I'm going to divide throughout by the under root of 4abc, because look at option A. Option A tells me that there is some relation which has a, b and c in the denominator under a root. So let me divide this expression throughout by under root of 4abc. And I see that I get the under root of c plus the under root of b equal to the under root of a, which is given in option A. So option A is in fact the correct answer to this question. This question was a very beautiful question, did not actually involve many concepts from your 11th and 12th standard. This question was all about Pythagoras theorem. It was about visualizing the question, drawing the right figure, and then applying Pythagoras theorem. As simple as that. But then this was a high order thinking question, and I like this question because this question actually would have been the difference between the one who got a higher rank and a lower rank. So if you get this question right, be sure that you will get a better rank than any other student, because this was a challenging question. Yet another question which was interesting from coordinate geometry, though not as involving as the previous question, but this still was a very beautiful question. So in this question, we've been given a parabola. Now this parabola has its vertex 2 units and its focus 4 units from the origin, and it's been further told that the vertex and the focus lies along the x-axis. So this is how the parabola is going to look, because its vertex is at 2, 0, focus is at 4, 0. Now the objective of this question is to find out which of the 4 points given do not lie on the parabola. Now this is not a very straightforward and simple question, because we've been given the vertex and the focus. Now how do we find out the equation of the parabola? An interesting question, because this is where the definition of the parabola will come into picture. Now, where is the directrix of this parabola? The vertex is going to be the midpoint of the line joining the focus and the directrix. The perpendicular from the focus to the directrix, the midpoint of that line is going to be my vertex. So actually the directrix is going to be the y-axis in this case, because the focus is at 4, 0, the vertex is at 2, 0, and the directrix is going to be the y-axis in this case. So what am I supposed to do? I'm going to use the definition of the parabola. Any point of the parabola is going to be at an equal distance from the focus and the directrix. I'm just going to use this formula, and I will get x minus 4 the whole square plus y square equal to x square if I consider any random point xy on the parabola, because the equation of the directrix is x equal to 0, because the y-axis is my directrix. So this is how I will arrive at the equation of the parabola. This was not the standard way of arriving at the equation of a parabola, because generally if the vertex is given and the focus is given, we can find out the equation of the parabola as y minus k the whole square is equal to 4a times x minus h, right? Here a was equal to 2. A was the distance between the vertex and the focus. A lot of you will not know this formula, so don't use this formula unless you understand what the different terms of this formula mean. So let's use the definition of the parabola and arrive at the equation of the parabola. So if you simplify this, the equation of the parabola reduces to y square is equal to 8x minus 16. And now just plug in the values of the different coordinates that are given, and you will easily find out that 8, 6 does not lie on this parabola. That was an easy part, plugging in the different values, though a little cumbersome. That is the easy part. The difficult part is arriving at the equation of the parabola. The first thing you have to do is visualize the parabola, then arrive at its equation using the definition of the parabola. Then solving this question is very, very simple. It was not a difficult question, slightly challenging because it involved you to think a little outside the box. So 2 coordinate geometry questions this time were slightly tricky, but not at all difficult. Let's have a look at another question from coordinate geometry before we move on to other sections. This was a question from vectors. Now, a very interesting question. See, in the main examination, they will not skip any section or any chapter from the NCERT textbook. So there was a question from conic sections. In fact, there were 2 questions. Then there was a question from vectors. There were a few questions from 3D geometry. So every section of your NCERT textbook will be basically tested in the main examination. So this question from vectors, we have been given a vector A, which is I minus j, and then we've been given a vector B, which is I plus j plus k. And then we've been given a few relations. We've been told that A cross C plus the vector B is 0 and A dot C is 4. Using all this, the objective of the question is to find out what is the magnitude of vector C, the whole square. This question also is a little tricky because you need to know what are the steps that you have to follow in this question to arrive at the answer. Of course, the first thing that you're going to do is, because you have A cross C plus B equal to 0, you can write A cross C to be equal to negative of B. What do you do next? Now you have been given the value of A dot C. You have to somehow use that. You have A cross C. What if I cross A cross C with A? If I cross A cross C with A, what do I get? It's a vector triple product. So A cross C crossed with A will give me an A dot A in the direction of C. Now A dot A, very easy to find out because I know what is vector A, minus C dot A in the direction of A. I know what is C dot A because A dot C and C dot A are exactly the same. So if I cross A cross C with A, I can actually get the left hand side all in terms of vector C, isn't it? What will happen on the right hand side? I'll have to cross the right hand side also with A, which means I get the negative of B cross A. Can I not find out B cross A? I can definitely find out B cross A, isn't it? Because I know what is vector B, I know what is vector A, so B cross A can be easily found out, and I'm going to use the determinant method to find out what is B cross A. Here is the determinant method, a very easy method. And using this determinant method, I arrive at what is B cross A. So my B cross A is I plus j minus 2k. So I know what is the right hand side as well. So what is A dot A? A is I minus j. A dot A will be 1 plus 1, which is equal to 2. Straightforward. I have got out what is A dot A. I know what is C dot A or A dot C, which is equal to 4. So I have 2c minus 4 times the vector A. Now the vector A is I minus j, so I can write it as minus of 4 times I minus j, which will be minus 4i plus 4j, equal to the negative of B cross A, which is this vector here. So 2c turns out to be the vector which is 3i minus 5j plus 2k. And I just need to find out what is the magnitude of C and then square it. The magnitude of C square will be 1/4 of 5 square plus 3 square plus 2 square, which turns out to be equal to 38 divided by 4. 38 divided by 4 will simplify to 19 divided by 2, given in option A. A very simple question from vectors. Again, the trick was, what do you do with the information that is given? If you know how to process the information that is given, this question was also another question which you could have easily solved in less than 2 minutes. Another very simple question in this examination. All that you needed to know was the first step. If you knew the first step, done. Practice will be very, very important when I'm going to solve this 3D question, because if you have not practiced a question of this kind, there's no way you will arrive at the solution. So they've told us that a plane is basically passing through the intersection of 2 other planes, and it is also said to be parallel to the y-axis. The objective is to find out which point lies on the plane and which does not. So this was the question from 3D geometry. So as we have seen, the objective is to find out the equation of the plane. So once we find out the equation of the plane, we can substitute the coordinates of the points and see which point lies on the plane. But the first thing is we have to find out the equation of the plane. So substituting the points in the equation of the plane is the easiest task. Finding the equation of the plane is not so easy, but in fact this question is very simple because the plane which we have to find out passes through the intersection of two other planes, and the equation of those two planes have been given, which means that finding the equation of this plane should actually be easy. If there are two planes whose equations are given and a plane passes through its intersection, then the equation of that plane which passes through the intersection will be the equation of the first plane plus some scalar times the equation of the second plane. As simple as that. So I'm going to write the equation of the first term plus lambda times the equation of the second plane. So the equation of the first plane plus lambda times the equation of the second plane equal to 0 is the equation of the plane passing through their intersection. So now what I do is I am going to group the x's, the y's and the z's. So I am going to get the direction ratios of the normal to this plane, right? And they've given us a condition. What is the condition that they've given us? The condition that is given to us is the fact that it is parallel to the y-axis. So if it is parallel to the y-axis, this means the direction ratio of the normal to the plane in the y direction is going to be 0. So my 1 plus 3 lambda, which is basically the direction ratio of the normal of the plane in the y direction, is going to be equal to 0. So 1 plus 3 lambda equal to 0 immediately gives me the value of lambda to be equal to minus 1 by 3. Now, if I know the value of lambda, how difficult is it to substitute the value of lambda and arrive at the equation of the plane? Again, a very simple question. All that you need to know is know the first step. And the first step will come to you only if you've solved a lot of questions. So, if you get that the first step, you will arrive at the equation of the plane, a very simple equation of the plane, x plus 4z minus 7 equal to 0. See, there's no y at all in the equation of this plane, which means that the normal, the direction ratio of the normal to this plane is 0 in the y direction. As simple as that. So, which means that our equation is actually correct. So, x plus 4z minus 7 is equal to 0. So if you look at the options very closely, you will see that the options are all in terms of 3's and 1's. When we look at the x and the z, we don't have to look at the y, remember, because there is no y in the equation of the plane. Look at the x's and the z's. The x's and the z's are all in terms of 3 and 1. And the constant in the equation of the plane is a negative 7. You have x plus 4z minus 7 is equal to 0. X is some 3, it can be a plus or minus 3, z can be a plus or minus 1 according to the option, which means x plus 4z, if x is 3, z is 1, will be 7. X plus 4z will be 7, 7 minus 7 will be 0, which means you have to look at the point which has x as positive 3 and y as positive 1, 3, 2, 1. That is the point which lies on the plane, the other points don't lie on the plane. This is how you become clever and arrive at the solution very easily. You don't substitute each and every point and see what happens. Very quickly look at these subtle details that are there in the options and arrive at the question and arrive at the solution to the question in a rather very smart way. In this way, you can save seconds. Imagine saving 10 seconds in 20 questions. That's a lot of time in a main examination, isn't it? You have saved 200 seconds, which is more than 3 minutes. And 3 minutes you can solve one whole question and get 4 more marks than the rest of the audience. So a very interesting way you are supposed to save time when it comes to the main examination questions. So was this question difficult? Not at all. In fact, all the questions from coordinate geometry were not really difficult if you knew how to start. And in order to know how to start, you should solve a lot of questions during the practice that leads to the JEE main examination. Coordinate geometry was the other section along with calculus, which fetches about 25 to 30% of questions in the JEE main examination. We left with 2 sections and now we'll move on to the next section, which is algebra. There were 9 questions from calculus, 8 questions from coordinate geometry, and a staggering 9 questions from algebra. When I talk about algebra, I am talking about chapters such as complex numbers, binomial theorem, sequences in series, trigonometry, and also matrices and determinants. So these are the wide variety of chapters which I'm calling under one section called as algebra. Questions from inequalities too, if they appear, I will put them under the section of algebra. Now, a lot of questions came from algebra, 9 of them in fact, but there was only one chapter which had 2 questions appearing from them, and that was the chapter on complex numbers. So the first question I'm going to solve is a complex number question. In this question, we've been told that alpha and beta are the 2 roots of the quadratic equation x square plus 2x plus 2 equal to 0. The objective is to find out alpha to the power 15 plus beta to the power 15. So we know what we have to do. We have to find out what are the values of alpha and beta. To all those of you who are wondering how is this a complex number question, I'm going to ask you to actually go back to quadratic equations and solve a lot of quadratic equations, so that as soon as you look at a quadratic equation, you can understand if the roots of these quadratic equations are going to be real or complex. Now, this quadratic equation clearly has complex roots, isn't it? Because the value of d, the discriminant, is equal to -4. So if my discriminant is negative, this means that my roots are going to be complex. So what are my 2 roots? I'm going to use the quadratic formula. Alpha and beta are going to be equal to -2 plus or minus the under root of d. What is the under root of d? The under root of d is -4, which can be written as root of 4i. Root of 4 is 2, so 2i. So -2 plus or minus 2i divided by 2, these are going to be my 2 complex roots. So alpha and beta are going to be -1 plus or minus I. I have alpha, I have beta in terms of complex numbers. Now I have to find out the 15th power of these complex numbers. Moivre's theorem, isn't it? As soon as you've been asked to find out the power of a complex number, Moivre's theorem should come into your mind. So now -1 plus or minus I, we are going to express this in their polar form. Modulus of both these complex numbers are √2, but the arguments vary, and they vary considerably. Because -1 plus I lies in the second quadrant, its argument is going to be pi minus tan inverse of 1 by 1, which is pi by 4. But the argument of the other complex number, -1 minus I, which lies in the third quadrant, is a little more tricky. It's minus of pi minus tan inverse of, again, 1 by 1 pi by 4. So the arguments are 3 pi by 4 and -3 pi by 4. So my alpha is √2 of cos 3 pi by 4 plus I sin 3 pi by 4, whereas my beta is √2 of cos of -3 pi by 4 plus I sin -3 pi by 4. The Moivre's theorem says that my complex number cos theta plus I sin theta raised to the power n, where n is a positive integer, gives me cos n theta plus I sin n theta. So my alpha to the 15th and beta to the 15th are going to be very, very simple to calculate once I've expressed my complex numbers in the polar form. I just need to take the sum of this. What will happen if I take the sum of these terms? The signs will cancel out, because sine of minus theta is minus sine theta. The signs will cancel out, which means alpha to the 15 plus beta to the 15 is going to be purely real. So I have √2 to the power 15, which can be written as 2 to the power 7 √2 into cos of 45 pi by 4. Now 45 pi by 4 is in fact 10 plus 5 pi by 4. 10 plus 5 pi by 4 can be written as just pi by 4, because cos is periodic across 2 pi. So cos of 5 pi by 4, pi plus pi by 4 lies in the third quadrant, which means it's going to be a negative number. So you have 2 to the power 8 √2 times negative of 1 by √2, and the √2 in the denominator and the numerator cancels out, and you're left with negative 2 to the power 8, which is negative 256. Now all these numerical calculations, very easy. You should just make sure you don't go wrong with them. But the trick is to convert the root into polar form and use de Moivre's theorem. If you know to do that, then you could have solved this question very easily. In fact, most of the algebra questions which came were very easy if you knew that one small trick. And as I have been reiterating throughout this lecture, that one small trick's knowledge will come only if you practice a lot of questions. I am going to say this a lot of times again in this video, so please bear with me, because it's very, very important that you solve lots and lots of questions, understanding the foundations of all these concepts. Let's look at another algebra question. This question deals with systems of equations. Now we have three equations and the options speak about the consistency and inconsistency of the solution based on values of A. Now this is another question that can be solved very easily, and in fact it can be solved without lifting your pen at all if you have sound understanding of the concepts. Look at equation 2 and look at equation 3. The x and the y coefficients are exactly the same. What will happen if the z coefficient of the third equation is exactly like the z coefficient of the second equation? Then equations 2 and 3 will become identical, right? What about equation 1? Is equation 1 anywhere similar to equation 2 or 3? Not at all. So if you have three equations such that two of the equations are identical, then what happens to that determinant? The determinant of the coefficient matrix will become 0. But what happens to d1, d2 and d3? d1, d2 and d3, remember, are the determinants of Cramer's rule, where we will be substituting one of the columns with the right hand side matrix. So what will happen to d1, d2, d3? Not all of d1, d2 and d3 will be 0. This means that the system of equations will be inconsistent. This means that the system of equation will not have any solution. And it's logically correct as well, because you have one equation and then two other equations which are exactly the same. This means that you have two equations and three variables. You cannot solve this equation. In fact, it is wrong to say that this system of equation has no solutions. It is correct to say that this system of equation is inconsistent. So if the coefficient of z in the third equation and the coefficient of z in the second equation become equal, the system will become inconsistent. Let us check if one of the options given actually matches this. So if a square minus 1 equal to 2, then my a will be equal to root 3. So when a equal to root 3, my system of equations will be inconsistent. This is one of the options given. So the option which says that when a equal to root 3, the system of equations is inconsistent is the correct answer to this question. There was no need for you to lift the pen to solve this question. It was a logical question, and if you had sound understanding of what happens when you're solving systems of equations, you could have solved this question in 10 seconds. Just 10 seconds. It was one of the easiest questions in the question paper with a slight twist. The next question I'm going to solve from Binomial Theorem. Again, a question which does not seem like a Binomial Theorem question, but was in fact a Binomial Theorem question. So we've been given that the fractional part of 2 to the power 403 divided by 15 is k by 15. The objective, of course, is to find out what is k. Now, how is this a binomial theorem question, you ask me, right? Let me tell you how. So I am going to write 2 to the power 403 as 2 cube multiplied by 2 to the power 400. You might be again asking me, why is this man doing this? The reason is 16 can be expressed as 15 plus 1, remember. And if I take 15 plus 1 to any power n, according to binomial theorem, 15 plus 1 to any power n will have n plus 1 terms, but the first n terms of that expansion is going to be divisible by 15, right? So I have a 15 in the denominator. So if I write 15 plus 1 to the power n, I can write it as n terms which are multiples of 15, and then the last term which is not going to be a multiple of 15. Now 2 to the power 400 is 2 to the power 4 all to the power 100, isn't it? And 2 to the power 4 is 16. This is how this question is a binomial theorem question. I agree that this is not a standard question and it is difficult to visualize this question in the way that I have told you. There is only one way in which you can arrive at this, and that is through a lot of practice. Again, practice. So 2 to the power 403 is written as 2 cube multiplied by 2 to the power 400, and 2 to the power 400 is 16 to the power 100. 16 to the power 100 can be written as 15 plus 1 to the power 100, and using binomial theorem, I'm going to expand this to get 101 terms, out of which the first 100 terms are multiples of 15. So I can write this as 15 lambda plus, what is the last term? The last term is going to be 100 C100. And what is 100 C100? 100 C100 is going to be 1. So 1 times 1 to the power 100. So 1 to the power 100 is also 1. So the last term is actually 1. So you have 15 times some integer m plus 1. So now I have written 2 to the power 403 divided by 15 as 8 by 15 times 15m plus 1. Now, what is the fractional part of this? The fractional part of this is nothing but 8 by 15 times 1, which is equal to 8 by 15. The question says that this is equal to k by 15. So the correct answer for k is k equal to 8. A slightly tricky question, wasn't it? It was a little tricky, but then in order to arrive at the solution, this is the only method that will put you on the right path. And how do you know that this is the method that you have to use? Solve a wide variety of questions. This wasn't an easy question, I agree, but this was definitely not a question that should have stumped you if your preparation for the main examination is very sound. I hope you had a lot of fun solving this question. Let's solve a few more questions and make sure that your preparation for the main examination is put right back on track, because then you will know what are the sorts of questions that you need to practice. So we've solved a couple of very interesting questions from algebra. Now I'm going to take you through a straightforward, simple question which came from the chapter on progressions. So here is a question which came from the chapter on progressions. What has been given in this question? We've been told that there are 30 terms which are in AP. And the sum of these 30 terms of the AP is designated as S. T is the sum of 15 odd terms of this AP. The relation between S and T is such that S minus 2T is 75. Further, we've been told that the fifth term of this AP is 27, with the objective to find the 10th term. It's a very simple, straightforward question, but involves a little bit of calculations. So S equal to 15 times 2A1 plus 29D. N is 30, so 30 by 2 is 15. So 15 times 2A1 plus 29D, where D would be the common difference. Now, what is T? T is the sum of the odd terms, the first term, the third term, the fifth term, until the 29th term. So there are 15 odd terms. Now, are these odd terms in an AP? Of course they are. The common difference, however, is not D, but 2D. So what is T? T would be 15 divided by 2. 2 times A1 plus N minus 1 would be 14. 14 times, instead of D, 2D, so gives me a 28D. I can cancel out the 2's with all the 2's in the numerator and get this to be equal to 15 times A1 plus 14D. Very simple, isn't it? Now they've told us that S minus 2T is 75. S was 15 times 2A1 plus 29D. T was 15 times A1 plus 14D. Right? Now 2T would be 15 times 2A1 plus 28D. Now if I take this difference of S and 2T, the two A1s inside the brackets will cancel off and I will be left with 15 times 29D minus 15 times 28D, which is 15 times D. Then 15 times D would be equal to 75, which gives me the value of D to be equal to 75 divided by 15, which is nothing but 5. Found out the value of D. I just need to find out the value of A, and for that they have told me the fifth term of the AP is 27. So A1 plus 4d is 27, d is 5, so a1, the first term a would be equal to 7. Now how difficult is it to find the 10th term? That's a walk in the park. So the 10th term would be equal to 7 plus 9 times 5, which is 45. 7 plus 45 is 52. 52 given in option D is the correct answer to this question. A very, very simple question, straightforward question. If you've done NCERT, or in fact, if you've done 10th standard AP, this is more than enough to solve this question. A very simple question that you should never forget to solve from this question paper. It was not even long. Even with all the calculation, you could have done this in less than 2 minutes. A very simple question. The next question from algebra would be a trigonometry question. Well, I have considered trigonometry under the umbrella of algebra. So I'm going to solve a trigonometry question. So far, I have solved questions which, though a tricky, could have all been solved in less than 2 minutes. From now on, I'm going to solve a few questions which you should attempt only if you have a lot of time. These questions are not difficult, but they're actually very lengthy questions, and arriving at the solution will take some time. Let's look at this trigonometry question and you'll understand what I am trying to point at. So you have to simplify this trigonometric expression. This is a very cumbersome question, involves a lot of tricks, and some of these tricks may not even seem logical, but somehow you have to arrive at the solution. So look at the options and somehow do manipulations to arrive at the solution. The first thing that I'm going to do is I'm going to write sine theta minus cos theta the whole power 4 as sine theta minus cos theta the whole square. Why do I do that? Sine theta minus cos theta the whole square can be written as sine square theta plus cos square theta minus 2 sine theta cos theta, which is nothing but 1 minus sine 2 theta, and because it's all raised to square, we have 1 minus sine 2 theta the whole square. That's the simplification of sine theta minus cos theta to the power 4. Now sine theta plus cos theta the whole square, I'm going to use the same logic, will become sine square theta plus cos square theta plus 2 sine theta cos theta, which is nothing but 1 plus sine 2 theta. I'm going to not touch the third term for now. That term is going to just stay as it is. As and when there is a requirement, we'll touch that term. Let's try and simplify the first two terms here. Now I have 1 minus sine 2 theta the whole square. Now I'm going to open the bracket there and I'm going to write this as 1 plus sine square 2 theta minus 2 sine 2 theta. Okay, I do that because I have a 3 here, and upon opening the bracket I get a 2 sine theta, 2 sine 2 theta, so I get a total of negative 6 sine 2 theta, and if you see here I have 6 sine 2 theta. Now all these are things that are not very natural. It's not an instinct that comes to your head, but if you see trigonometry questions, generally trigonometry questions are like that. Sometimes the trick isn't very obvious. You just need to make sure that you do a lot of practice and then make sure that in the examination hall these ideas come to your head. It's not a natural idea, I agree, but this is how you solve this question. So you expand 1 minus sine 2 theta the whole square, and then you get the 3 times negative 2 sine 2 theta, which cancels with the 6 sine 2 theta term, and you will be left with 3 times 1 plus sine square 2 theta plus 6 plus sine power 6 theta, which is multiplied by 4. So now my whole expression has simplified to 9 plus 3 sine square 2 theta plus 4 sine to the power 6 theta. Now this is also not one of the options which is given, which means I have to do further simplifications. This is going to be a little tricky. Now sine square 2 theta, let's go back to sine theta cos theta. Let's not use 2 thetas anymore. We've done the simplification with 2 thetas. So I'm going to write sine square 2 theta as 2 sine theta cos theta to get a 12 sine square theta cos square theta term, right? And now I have a sine power 6 theta. I'm going to write it as sine square theta the whole cube and sine square theta as 1 minus cos square theta the whole cube. Now why did I do this? The reason why I did this is because I can do a little more simplification if I use a minus b the whole cube formula, I will get a lot of 3's. 3's when multiplied by 4 give me a 12, and I see a 12 here. So that is how I am going to simplify this question. Again, not a very natural instinct, but unfortunately that is how you solve this question. So what you do next is you are going to write sine square theta as 1 minus cos square theta. So you will actually get 12 cos square theta minus 12 cos power 4 theta. And if you expand 1 minus cos square theta the whole cube, you're actually going to get cos square thetas and cos power 4 theta to have the coefficient is 3, which upon multiplied by 4 will give you a 12, and hopefully they will cancel out. So that is exactly what is going to happen, because if you expand, you are going to get 12 times 1 minus cos square theta into cos square theta. So you'll have a negative 12 cos power 4 theta. So this term which I cancelled was a negative 12 cos power 4 theta, and you have a 12 cos power 4 theta in the other expansion. Similarly, you have a positive 12 cos square theta and a negative 12 cos square theta, and they cancel out. You're left with 9 here, 4 here, and negative 4 cos power 6 theta here. You're left with 13 minus 4 cos power 6 theta. That is given in option A. Option A was the correct answer to this question. But you see, this question is not an easy question. The instincts that are required to solve these questions are not natural. So this is a question that you attempt only if you are sure that you've solved 20-25 questions, because this is a long question, not an easy question to attempt, not in terms of the concepts, but in terms of the steps that is involved. So in the main examination, you generally get 2 or 3 such lengthy questions, which are only meant for students who want to score 100% marks. And these have to be attempted at the fag end of the examination. You should make sure that these questions don't eat up your valuable time to solve easier questions. So we've looked at calculus, coordinate geometry, and algebra. A lot of questions came from there. 8, 8, and 10. 26 out of 30 questions came from that section, which leaves us with 4 questions and the last set of chapters. Now, I'm going to group all these chapters into one section: probability, statistics, mathematical reasoning, and all the other one-odd chapters which are there in your syllabus. So there were 2 questions which came from probability and permutations and combinations. There was 1 statistics question, and there was 1 question from mathematical reasoning in the main examination. So in fact, main examination, make sure that every chapter of your NCERT textbook other than linear programming is seen. So in the main examination, every chapter there will be a question. You will have to make sure that you go through the entire syllabus of NCERT to make sure that you can attempt all these questions. Just now we saw a trigonometry question which was very lengthy. In fact, there was 1 more question in this question paper that was extremely lengthy and should have been attempted at the fag end of the examination after every other question was done. And this was a question from statistics. So what is given in the question? There were 5 students, their average height was 150 centimeters and their variance was 18 square centimeters. A 6th student was added to the group and his height was 156 centimeters. The objective was to find out what is the new variance now. Now this was a very long question because you have to solve it procedurally and arrive at the solution. There are no tricks. Plus, this question was intensive on numerical calculations. I'll show you how to solve this question. If such questions appear in the examinations, please don't solve them in the beginning and don't waste your valuable time which you could have utilized to solve easier, simpler, logical questions. So let's try and solve this question from statistics. They've told us that the mean is equal to 150. So summation xi's, I running from 1 to 5, divided by 5 equal to 150, which means that the summation xii from 1 to 5 is 750. So the sum of the heights of the 5 students was 750. So if a 6th student is added, then the sum of the heights of the 6 students is 750 plus 156, which is 906. And the new mean would be 906 divided by 6, which would be 151 centimeters. So calculating the mean, easy. But the variance is going to be calculation intensive. So let's look at how the variance had to be calculated. We're going to use the formula for the variance. So I'm going to call the variance as sigma square. So sigma square is summation as I runs from 1 to 5 of xi square divided by 5 minus the square of the mean. And this was equal to 18. What was the old mean? The old mean was 150. So the square of the old mean was 150 square, which is 2,500, or in other words, it would be 22,500. 15 square is 225, which is why I said it's 2,500. 22,500. Now, summation xi square divided by 5 minus 22,500 was equal to 18. Now I take a common denominator of 5, multiply everything through 5. Then I get the summation of xi square I running from 1 to 5 to be equal to 90 plus 5 times 22,500. Now this is an intensive calculation, and this turns out to be equal to 1,12,590. That's a calculation through which you will arrive at that answer. But it's not an easy calculation. So as I've told you, this is a calculation intensive question with a small silly mistake which will penalize you heavily, because this is an MCQ kind of environment wherein marks are awarded only for the final correct answer. So if you go wrong with calculations, your entire effort and time would be a waste. So you have found out what is summation xi square as I runs from 1 to 5. Now a new student was added. So the new variance would be summation xi square I running from 1 to 6. But you know the summation xi squares of I running from 1 to 5, add 156 square to it and divide by 6 and subtract the new mean square, which is 151 square. Now you understand how intensive on calculations is this question. You simplify the whole thing, you will arrive at 20 as the correct answer. The effort that goes into solving this question is worth only if you have attempted all the other 29 questions and are sure that you have marked them properly and you have time, then you solve these questions. In fact, solve physics, chemistry and every other math question and only then come to this question, which is monstrous because of the calculations that were involved to arrive at the solution. After seeing that statistics question which you are supposed to attempt at the fag end, let's look at a probability question. This question from probability is quite straightforward. Now they've given us a well shuffled deck of cards and we are taking 2 cards from there with replacement. X denotes the event for the number of aces drawn when you draw these 2 cards with replacement. The objective of the question is very simple. Find out the probability that x is equal to 1 and add to it the probability that x is equal to 2. P of x is equal to 1 plus P of x is equal to 2. This is what we have to find out. So let's get into action and solve this question. 2 cards were picked with replacement. So what is the probability that you get x is equal to 1? Either the first card can be an ace or the second card can be an ace. So it's going to be 4c1 divided by 52c1 multiplied by 48c1 divided by 52c1, not 51c1, because it's replacement, right? So the first card can be an ace in so many ways. And the second card can be an ace in actually the same number of ways, because it's going to be 48c1 divided by 52c1 multiplied by 4c1 divided by 52c1 again. So the whole thing is going to get multiplied by 2. So that is how you're going to get x is equal to 1. To get x is equal to 2, well, actually this is simpler than the first calculation, but this is where students will go wrong. People have the tendency to write 4c2 divided by 52c2. That is wrong, because here we are doing replacement. So the probability that x is equal to 2 is 4c1 by 52c1 into 4c1 by 52c1. That's the correct answer, because this is a question with replacement. That was the only trick in this question, a very simple question, but a lot of students will go wrong because they would have written that the probability of x is equal to 2 is equal to 52c2 in the denominator and 4c2 in the numerator. That would have been a blunder. Now you have to just simplify these combinations, and upon simplifying the combination, you will arrive at the solution, which is 25 divided by 169. This was given in option B, so option B was the correct answer to this very simple probability question. Unlike the statistics question, this is a question you solve as soon as you see this question. As soon as your eye go towards this question, you solve this question because this is a very simple question. And of course, avoid committing the mistake that would have led to a wrong answer. So now we have seen more or less the entire question paper, barring one section, which is mathematical reasoning. Now, a question did appear from mathematical reasoning like every other JEE main paper, but this year's mathematical reasoning question was not a very straightforward question. It was a little difficult, a little tricky, but a very beautiful logical question. This was the question that appeared from mathematical reasoning in this question paper of the JEE main examination of 2019. This statement was given to us, and the objective was to find out the correct ordered pair for these beautiful looking symbols, the plus inside a circle and a dot inside a circle. So in order to solve this question, what I'm going to do is I am going to distribute the and which is here over these two beautiful looking symbols. So I get a P and negation P with that dot with Q, and then that is going to get an operation which is going to be the plus, and then Q and the entire expression negation P with the dot and Q. Let's further simplify this. P and negation P. What is P and negation P? P and negation P is a fallacy. It can never be true, right? P and negation P is a fallacy. So fallacy and that beautiful dot with the expression P and Q, and then the plus with the entire expression on the next expression. I'm not going to simplify that a lot. I will just distribute the and inside. I get Q and negation P with the dot of Q and Q. Q and Q is just Q, nothing else but Q. Now we've been told that this entire expression which is here is equal to P and Q, right? If this entire expression is equal to P and Q, we have to use a little bit of logic here. A fallacy and a P and a Q is here, correct? Now, what happens when you and a fallacy? If you and a fallacy, the entire thing becomes false, because false and something is false. So my guess is that this symbol has to be an OR. So I feel that my dot has to be an OR, correct? So then my fallacy or P and Q will reduce to P and Q, and I still have this plus. I don't know what the plus is, and my right hand side now becomes, in fact the second expression becomes Q and negation P with that beautiful dot. I know what the dot is now. The dot is nothing but OR Q, correct? You have P and Q with some operation and this right hand side here. Look at the right hand side, and this is where your logic has to kick in. You have Q or Q in both the sides of the operator OR. So the Q's are there on both the sides of the operator. So what will happen to the right hand side? In fact, if you see, the right hand side is going to behave exactly like how Q would behave. If you look at the truth table, this would behave exactly like how Q would behave. So P and Q with some operation with a Q has to give you P and Q. So I feel that this operation has to be an AND. If you don't trust me, you will then have to go and make the truth table for this entire expression, and then you will find out that if the dot was an OR and the plus was an AND, then the entire expression will have the same truth values as P and Q. A slightly twisted and tricky mathematical reasoning question, but this is a beautiful question, and it involves subtle details of mathematical reasoning that you have to understand. So basically, if you understand mathematical reasoning, then solving this question would have been easy. Though it involves a little bit of guesswork, it still is a very straightforward question. So that's about it. That's about how the JEE main paper was, the first paper of JEE main 2019. It had 8 questions coming from calculus, 9 questions from coordinate geometry, 9 questions from the huge section of algebra which included trigonometry and matrices, and 4 questions from PNC, probability, statistics, and mathematical reasoning. The paper was not a difficult paper. Most of the questions were very simple. 25 of these questions were straightforward questions if you knew NCERT syllabus. 1 or 2 questions were slightly lengthy, and there were just 2 questions, both of them mostly from coordinate geometry, which were slightly tricky. So anyone who was trying to get 25 math questions correct should have got them right if that person knows the NCERT textbook inside out and has a very strong grip on the foundations of 11th and 12th standard concepts. JEE main, not a difficult examination if you've practiced well throughout the 2 years of your JEE preparation. JEE main is not something you should be scared of. Just practice well and make sure that you've seen a wide variety of questions and you're well aware of the NCERT syllabus. I'll see you again with more such analysis videos, and all of you have a great time preparing for the JEE main examination, and I will see you very soon.
For more videos and live lectures on the JEE, click on the subscribe button now.